Hi, and thank you for having me here at API Days New York. I'm so excited to be able to join all of you today, and I sure have a lot of slides for you all today. I'm going to try to go through these relatively quick. I've got some newer topics today that I'm really excited about that I want to present to you. Buckle in, save your hate mail for the end. I'm hoping that you'll see the light the way that I see it by the end of this talk. But I'm going to go ahead and just start by introducing the title here, and then we're going to do a little intro slide just to give you some background on who I am. The talk today is on code first versus schema first versus model first versus GraphQL first driven GraphQL APIs. Now, with that being said, this talk's not actually about GraphQL. No, this talk is actually about shipping APIs that scale at scale. And this is a topic that's really important because if you've ever written GraphQL APIs by hand, the at scale part is a little bit challenging. There's a lot of tools out there that allow you to ship a scalable GraphQL API, but being able to do that in a scalable way across business orgs and everything else that you have to worry about is less helpful. So I'm hoping that I'm going to propose some ideas here that might be able to help kind of solve some of that. Let's give a quick rundown of what we're actually covering today. So first of all, I'm going to give you a little intro, help you understand where I'm coming from this perspective. We're going to be defining a few of the terms that I'm referring to here, code first, schema first, like what's going on. We're going to have a look at the pros and cons then in a little bit more of an analytical way. This is going to be based on or fueled by my experiences, like working with customers in this space for a long time now. And then we're going to actually be making a case for why I think model first is the right approach, as you might have guessed based on the title. And then we're going to be doing a little bit of demo and Q&A. Sorry, no Q&A for you, but if you come to the live event, I'll be there for you. So, but we'll do a little demo and that'll be fun. So that being said, we're going to do a little bit of intro here. Who am I? So I've actually been around the API Days space a fair amount, running some of the GraphQL tracks. So you may know me from some of those kind of events in the past. Otherwise, I've been actually in the GraphQL educator space for over 5 years now. I am no longer a developer relations person. I've just recently switched over to senior sales engineer at Hasura. Super excited to not just be generic with my pitching of GraphQL, but now I'm right inside of your companies, hoping to convince your bosses that using GraphQL is the way to go, and hopefully you will think that Hasura is the way to go, as I do. But that's secondary. That being said, a little bit of my background as a person. I'm a dad of 4 kids. So I might be really tired and I might ramble a little bit, but bear with me. I'm a hobby maker. I'm really into the embedded code space, and I like hobby distillation. And I'm also a kettlebell mostly collector these days, but I do like to throw them around every now and then. I'm also formerly a software engineer. I have a background in digital strategy, branding. I was a consultant and done some software architecture as well, and obviously developer relations for the last majority of those years. But that's basically all you need to know about me. About Hasura, if you're brand new to it, here's just kind of a quick throw-up diagram for you. It sort of tells you a little bit where it sits. Hasura is an engine that will take incoming GraphQL queries. It will apply rules that you've defined on those, and it will then convert those queries into requests against your underlying data source, like skipping the resolver step. So you're able to actually say, if I'm going to query something from a database, Hasura is going to take that plus the rules and actually generate the performant SQL or REST requests against the data source you've defined, so that you can skip the resolvers, you can skip a lot of the boilerplate and be able to work quickly. We'll see a little piece of that later on, but this is also not entirely about what is Hasura talk, although it does feature a little bit heavier towards the end. And then just one more time, more visualized, if for those that kind of want to see how that happens. So Hasura sort of sits in the middle, incoming GraphQL query from a client, and then we run the engine, and then it actually spits out a SQL statement against the database. Handles N+1 issues, gives you really performant database utilization, the things that people who ship scalable APIs care about, like you. If this is interesting to you and you'd like to find out more, actually, we have HasuraCon coming up on June 20th to the 22nd. It's going to be great. It's going to be a lot of fun. You might even see me kind of hanging around. It's online. It's totally free, but this is a great place to hear more about it. I would encourage you to sign up. Would love to have you ping me in chat and say hi, and it'll be really a good time. So if you're into this kind of topic, it's interesting, join it. I only have a couple more slides pitching the company. I'm sorry. Deborah habits is what I got to do. But we are used by a lot of big companies. So if you're kind of looking into something that might solve your specific space, I mean, this is just a small handful, but you can see that title at the top there, top 44 or 44 of the top 100 Fortune 100 companies are using us already. So this is just small sampling, but like you might have heard of General Mills. If not, you've heard of Cheerios. I know that. But so there's a lot of companies that are using us. And so feel free to feel safe. And the last piece is we've crossed over 500 million downloads. We're actually heading up on a crazy trajectory. We're just short of 30,000 stars on GitHub. Go give us a couple of stars. But people are using this all over the place. It does have an open source core. We love the community. So super excited if you are excited about these things. Okay, pitch over. We're going to go now into defining some of the terms that we started off with, starting with this code first, schema first, model first, GraphQL. Now I'm going to go ahead and give you the quick breakdown of the GraphQL definition that I'm meaning. I'm meaning this holistically about the fact that GraphQL is both the schema, like a schema part where you define what the data pieces are. It's like a map to your data, and then you actually have the resolvers usually that you have to write to map to that schema, and then you have the query language, and then there's the execution engine, which is a specification that says if I map all those pieces together, it should perform this way or behave this way. I know what you're thinking right about now. You're saying this was not supposed to be a talk about what GraphQL is. Well, I give you that, but I'm wanting to kind of harp on the actual point here that these pieces, the schema, the resolvers, even the actual queries you're sending to the engine or to the server are usually all pieces you have to write. And that is less fun. And that's where we start to see some of the pain points that arise with GraphQL. And specifically, if you're trying to build out those resolver pieces, because you've got to connect to databases, microservices, other integrations, less and less fun as you go along, because again, it's more and more stuff that you have to write, you have to maintain, to the point that a lot of people, when they start to kind of shy away from GraphQL, is because it doesn't feel right. All right, that was a pun. You like that? That was free. I told you I'm a dad, so dad jokes are coming fast and furious for you. But like this is fair, because they're like, yeah, great. I moved away from having to maintain a bunch of bespoke endpoints for my REST API just to go write a whole bunch of resolvers and a bunch of glue code, and I have to reinvent the patterns like caching and authorization. This doesn't feel like this promise of just write this beautiful syntax and I get data magically. People have that real pain point. And that brings us to sort of the approaches of how people come to writing GraphQL servers. And this is where we see a lot of the issues arise. And so we're going to start with kind of looking at the first one here. And the first one that we often see is a code first approach. Now, code first, we're going to have a look at it. It's also known sometimes as the resolver pattern. This is where you go about writing your resolver in line in some sort of a larger data spec that will be executed in whatever your language of choice is. But you're kind of defining the resolvers. And from that definition of the resolvers, the way you're fetching the data, those fields that you're putting on that object become your schema. And it is a good approach because it actually lets you start writing really fast. Like if you know the front end code that you're going to be writing and you know your data, you can get going really, really, really quickly. But so we're going to go into the pros and cons later on. I'm getting ahead of myself. But this is what code first means, is it's this approach of having the writing your resolvers and then inferring your schema from there. Looking at a schema first approach, it's actually doing both halves, but there are benefits to it, which we'll get into the pros and cons. But the schema first approach, where you're writing both the schemas and the resolvers, it looks more like this. So you're actually writing the SDL of what a GraphQL schema would be, and then you're also writing the mapping resolvers to it. I'm really fighting here, not going into the pros and cons already, but we'll get there. We're just defining terms right now. And then we have model first. And model first is this entity-driven approach where it's actually technically GraphQL agnostic, where you give it a definition of, these are my models inside of my API or my ecosystem, and then you're going to have to build out a lot of tooling to support that. Again, pros and cons coming right up. So let's go ahead and jump right into this here. So pros and cons, and I want to go ahead and state our hypotheticals here. So we're going to kind of look at this through the lens of 3 different use cases. There's going to be the small team, or maybe one or few developers with one project. We're kind of looking at through that lens of the pros and cons. Then there's going to be organizations with dozens of engineers and projects. And then you're going to even have multinationals that have to work with even being an integration target. Like somebody has to consume yours, right? We're at API Days embedded models. Like this is going to be right here in this wheelhouse. And I'm also inventing a new term because I never give a talk where I don't invent at least one new term. So T1 LOAC is time to first line of application code, which is basically the time to happiness for developers about when they can actually switch away from doing all of the glue code and boilerplates and getting down to writing actual business logic. Okay. Hopefully you are all keeping up with me. I'm going to just assume that everybody listens as fast as I talk, and we're going to just go at this. This is recorded, so feel free to just drop it down a speed if you need to, or speed it up if you want to. Okay, code first approach. We're going to have a look at this. So essentially you have this was the one where you write resolvers first. This is the resolver pattern. Pros about this kind of boils down to, this is really good for small teams. Like really, like you can, if you know everything, if you're front to back, you're controlling the whole thing. That's where this pattern tends to really shine. And it's an engineer's delight, right? Because it's elegant. They're being able to write in the code of their choice. And it's just nice. Like they can kind of map things directly. Now I have a couple of, what I call abstract charts. I have cased those and color highlighted them appropriately. But I want to use these as talking points. So if you haven't caught on the humor there, then good on you. Like pure mind, pure eyes, very good. So what we're going to have here is some talking points about sort of where this fits. So for the small org, small ramp up where you have to write things, and then over time you kind of stay stable, right? The amount of time you're investing in over time, your developer velocity stays relatively stable as you've kind of put in the first initial effort, and then everything's kind of stable. You can kind of iterate, but you know the scope, you know the space, and it's okay. This is maintainable for small teams. But once you start going into some orgs, like where you start talking about like cross teams, you start to get this real ripple pattern, right? Because you're going to have the situation, and these are actually based off of observations I've had with people and with companies. You're having the effect where as soon as you have to ramp on a new person, you're losing some velocity, and it really has a compound effect the more and more projects you're adding, because you're having to onboard new people with mental context, and there's a lot of challenges with this problem. Actually, I think I missed the pros and cons. So the pros here, it's a really fast time to first line of application code. It's very expressive in how you approach this, and it's operationally simple. Because again, you have the context. It is hard to scale across teams and onboard people. It's creating a runtime for a runtime, which I find kind of a weird paradigm. Like you're having to sort of write code that'll run the code to run the code. I don't. As meta, but I think that's just something that you have to bear in mind, that you're going to have to create a runtime for building out your code. And then it really limits meaningful participation in shaping the data layer. So if you've got other people to bring into this conversation, it does do some gatekeeping in terms of who gets to help shape the shape of the API. And then, so coming to the very last point then for this one, obviously, if you're talking about multinationals and larger companies, this thing just crumbles. And if you've tried this, because if you're writing this pattern, it's very hard to ship at scale, very hard to onboard teams that are maybe from all over the place with lots of different kinds of business constraints. So this is just a challenging pattern to code with in that regard. So speeding along, because I want to make sure we're sensitive on time here. Schema-first approach. It's good for orgs with teams. Like, it's actually helpful because your GraphQL document becomes sort of the design doc, and it's good for the GraphQL purists because they're like, this is beautiful. I get to define relationships in this schema, and that's amazing. Yeah. So pros, it's more declarative. Like, it's getting away from prescribing how to implement. It's really pure. It's shareable across orgs. So you can actually say, here's the document, and be very terse and explain what you're supposed to do. And design doc for the win. Like, this is just a nice way to communicate the API. It's the slowest time to one line of application code, first line application code. It is error prone because you're having to maintain the magic between the schema and the resolvers. And it's operationally complex because you're having to maintain all of this infrastructure yourself. So writing the schema and the resolvers slower, does help onboard teams. And, we can kind of see the BS chart here about how this sort of works out. You have a ramp up time every single time because you're having to implement code in two places, or write schemas and code in two places. Somewhat stable, but as you start to onboard more teams, you actually get a bit more stabilized because those teams can maintain developer velocity as you onboard more people, because there's more agreed upon understanding of the API, and there's pieces that are easier to understand as a group. So again, a lot of onboard time typically, but stabilizes for larger orgs, and people have been shipping software like this for a while. So this is definitely something that works on a global scale. I would argue model first is the way to go. It's good, and we're going to see the major drawbacks of it here in a minute. But it's good for teams of really any size. It's an architect's delight because you're really abstract. So pros, it's purely declarative. You're not giving any prescriptive details on how to run it. You're not even telling it that it has to be GraphQL. And then it's shareable across industries. It's really easy to understand, and Grok takes the best part of domain-driven, design-driven, and object-oriented, everything that architects love, and lets you work with these primitives. If you've been in the space a while, you know why all of those things have fizzled over time, because the parts of implementing them are really challenging. The cons are, without tooling, it is the slowest time to first line application code, because you're going to have to write something that reads, interprets, and executes models without any inference. That's challenging. And there's a lot of resistance. Actually, it's like the too good to be true resistance that this can't actually work. We've seen this come and go, and these things are always just so much more effort to actually maintain over time. And my BS chart kind of mimics this, right? So the first time you ship a product or a feature, and I marked this here as model first without tools on the first run, you have to write all of that code yourself that's able to take the models, figure out how to make an API out of it, figure out how to solve all the permissions and caching problems, and all of that is on you. And that is a loss to developer velocity, because you're having to reinvent all the wheels. But as soon as you have that tooling in place, you could actually just go. And and even if you're talking about across larger orgs, like, there's a little dip as you're having to sort of figure out how do these models not connect to each other, but that's actually a very efficient pattern of how to work. And so I would argue that if you have the tooling in place, and Hasura is trying to offer to be that tooling, you have an extremely short on-ramp time, because if you have tools that are already written that do this reading and inference and all of that and scaffold out the APIs, then it's short onboard, and then you're good to go. Because if you have these models, you can share them across orgs, it scales. If you have the tooling, you don't have to write it. And if you need a bunch of escape hatches and routes, that works for you. And in fact, I want to just give you a quick sort of demo here, if you will. This is what the GraphQL, this is what the Hasura console looks like. This is just kind of like the backend for your API. And it gives you this, this kind of ability here to have a look at what models are generated for you from using this console, where it just defines all of your relationships and edges. I want to just kind of show you here real fast, if I can. We have, I've added a Postgres database here. This is the real deal here. But I've added a Postgres database, and if I just go here and I say, hey, it's introspected and found all the models inside of my data set. If I just hit track all on this, what it's going to do is it's actually going to go ahead and generate like all of the relationships now based on the foreign keys. And my API is actually done. Like if I go to the Explorer here, we can see that we actually have everything that we would need. Like this is kind of crazy stuff here, right? You know, we can come down to albums. We can do something like album ID. We can run that. There's a really big data set. Like that's all there is to it, because the tooling is done. The tooling says, I don't care what your models are. Just give me models that I can read, and I'm able to actually do that for you. And that approach, I mean, this is literally a production GraphQL API. I can go with that right now. That approach with this thing is, when I want to make the case for model first, is that it's finally actually declarative, like the way that GraphQL always wanted to be. And it comes down to two unique properties and values of the model first approach, is that you're defining shapes and affordances. Now, if you allow me a sidestep into the design thinking here, affordances is basically saying that the way that something is shaped tells me what I can do with it. Not telling me how it needs to be done. It tells me what I could do with it. And like with the classic example from design school, you have the teapot, and looking at a teapot, you can see there's a handle, you can see there's a spout, and I can imagine, oh, I can guess that I, as an operator, could interact with this API by picking up the handle and pouring it out, and that might be some tea. And so my understanding of this from what it's showing me from the models is it has volume. It can be poured, it can be handled. So if I have a robot, if I have another person, if I have anything, I could train something else to read this model, look at its affordances, and know how to operate it. And that's the power of a model-driven approach here. If I go ahead and look at then another benefit is when I layer in permissions and have part of my model is actually the permissions of who has access to what, so declarative permissions in there, which again Hasura has, and the semantic relationships, I could actually just then also hide those affordances in certain contexts. Like this would be all that the outside world would be having understanding of this and would have no idea it's a teapot. It's like there's a canister there that has volume. There's no understanding of what's actually under there. And it really comes down to why this speed works so well is that essentially what we're arguing here is a model registry is actually better than schema registry, which my subtitle, what did he just say? And I mean that because a schema registry is absolutely in the right direction, but it didn't go far enough. There's a lower common denominator that we can publish and share with each other in a way that we're actually able to work with a code that I know. So a model registry allows me as a consumer to control the execution. I can tell the system how it should operate. So for Hasura, I take your models and I can give you an API. You could write the software to take the same models that I'm working with and write your own system, or use Hasura because we'll save you a whole lot of time. But like that is an incredibly powerful concept, and it's really driven by this secondary principle here, which is respecting the rule of least power, where we're wanting to find a complete but dense syntax that allows zero escalated permissions. Now, I like SQL, actually, I do. But you know, if you're talking about defining your data models through a concept like SQL, well, select lives really close to delete, right? And if you're trying to ship around files like this, you have a lot of additional concerns to worry about what can actually happen to your data set. Now, I'm really running out of time here, and I only have a couple more slides I want to hit with you. But so I want to make you aware of some shifts happening in the Hasura world. We have the Hasura metadata for a long time, which is how we did the API just now, and it's data models and great. We're proposing a specification called the GDS, which is the graph data specification. You can read all about it. It's YAML, and it'll support adjacent file types as well. But it allows you to define not just models of what can be operated with, but it can also define what I can do with it. Is it selectable? Is it averageable? Is it groupable? Like, what can I do with this model? And I can define all those things in a declarative way so that I actually don't have to give any prescriptive nature to the API runtime. And this is the holy grail. This is the pursuit of architects for a long time, is having a way to say this is something that we're trying to be able to create. Is I have business entities, I can do domain-driven design, and then get the API for free. Like, think about that for a minute, is that I'm focused on my models, and the API is secondary in a lot of ways. Critical, important, has to do all the things that APIs do, and this entire conference circuit is on that topic. But do I have to write that by hand? I'd argue you don't. There's ways to do this from a programmatic approach where we can think about the actual models that we're trying so hard to ship to each other, embed in other people's businesses, and get away from doing it by hand. So last two spicy takes. Model-driven is, my opinion, but I'm not going to say that. Model-driven is the best way to create any API. GraphQL, REST, or what else you're going to have. If you can do the models and generate the rest from there, that's really powerful. And the last thing I want to say, as I'm partially paid to say this, is that if you haven't looked at Hasura and you're doing GraphQL, you're likely losing money. And it's jokey, but I do mean it. I really, as a former DevRel, as also now as a sales engineer, have a look. You know, if you like this kind of approach, you like this kind of thinking, and you want to ship things at the scale of General Mills and Boeing and Airbus and hospitals and whatever else, if you like that stuff, have a look. There's an open source escape hatch if you really want to take the money and run. There's also a lot of services we provide, which is where we try to actually bring value. But it's something that I think is worth having a look at. That is the talk I have. I'll be live in person at the actual event. So if you have questions, come and find me. I'll be wearing probably this hat and maybe even a goofy jacket. But I'd love to talk with you. I hope you find this interesting as much as I do. And with that being said, I'm again very grateful for you having me today. Thank you for putting up with my opinionated slides. And yeah, it's been great talking to you all, and we'll see you around.